Since we have understood the pulse modulation technique, now let's concentrate on the second topic related to the digital communication system, that's line codes. Now the learning objective of this video lecture is that after going through this lecture, students should be able to define what is line coding and different basic types of line coding. They should also be able to specify at least the desirable properties of line codes and should be able to encode any binary data sequence into the three basic types of line code format. Let's understand what is line coding. Now, in that the output of the pulse code modulation or any pulse analog modulation technique which is followed by ADC is always in terms of bits. Now, these bits has to be mapped into electrical pulses or waveforms if you want to transmit it over wireless channel or wired channel. Basic definition in most of the literature says that the digital output of any source which gives in terms of bits is converted into electrical pulses for the purpose of transmission over the channel, and this process is called line coding. Now let us see an example of this. Now this is the example where you can get the idea about the classification of line code based on pulses also. Now see here, this is the clock, this is the clock period. Now this clock period consists comprised of the bit interval, the same as the bit interval. So this is nothing but the house for this bit 0, this is the house for the bit 1. Now there are two types of pulses that we have used here, non-return to 0 and return to 0. And both of them we have used for the on-off line coding, which we will see later on. But for time being, just keep it in mind that on-off line coding 0 is by no pulse or 0 level and bit 1 is with some positive level. Now see here in the NRZ, this 0 bit for this complete bit interval, it stick with the 0 level, and for bit 1, for the complete bit interval, the pulse retain its value. That is the some positive level. That's why it is non-return to 0. Within this complete time interval, it will never return to 0. When in the case of return to 0, if you see, here the first half bit is because of the 0 level, because of bit 0, and the next half is because it returned to 0. It will be more clear for the bit 1 that for the first half bit interval, it is positive and the next half it will return to 0. In terms of pulse shape, you can call this as a half width pulse, which is nothing but return to 0, and full width pulse, which is nothing but non-return to 0. Or you can say that we have chosen a pulse whose width is equal to bit interval TB for NRZ, and for the RZ we have chosen a pulse whose bit interval is equal to TB by 2. Now let's understand the different types of line codes based on the line coding format. There are many, but basically all of them can be categorized in the three forms. That is, one is on-off, another is polar, and the third one is bipolar. The name itself gives you some idea about on-off, polar, and bipolar. And most of the other line coding formats are the variants of these basic line codes. Now let's get into the on-off line code. Now here on-off line code, in some literature they have specified it as unipolar line code. Unipolar, unique, that is one, polarity. On, off. For some bit it is on, for some bit it is off. Just to remind you that in the digital communication, we are transmitting the information in terms of bits. So the receiver side, our aim is just to identify 0 and 1. So it's necessary that both of the bit 0 and 1 should be represented by two different levels. In the on-off case, the 0 is represented by 0 level and 1 is represented by positive 5 volt, or you can say positive level. Now if you see closely here, think yourself and specify whether it is an NRZ or RZ. Fine. Now the next one, that is the polar line code. Now see here in this polar line code, here polar means polarity, it has a polarity. So some positive and some negative, two different polarities. So if you see here one is represented by some positive level and 0 is represented by some negative level. So there are two different polarities representing zeros and 1, which in this case is negative level for 0 and positive level for 1. So if you closely see here, And please comment here also that whether it is an NRZ form or RZ form, and then we will discuss it in class. Now, if you go back and think about on-off. In the on-off, the level difference representing zeros and ones is half than that of the level difference representing zeros and one in polar. Or you can say it means that the probability that you make error in the polar is lesser compared to the on-off. Or if you keep the probability of error same, then the power required in the polar is going to be less. This will understand detail in the class. The third type of line code, that is bipolar line code, which is also specified as alternate mark inversion, or the another name is pseudo-ternary. In this case, if you see closely, all the 0 bit is represented by 0 level and 1 is represented by either plus positive level or negative level, and it follows some pattern. See here, when the consecutive 1 comes, the next one comes, it will alternate the sign. So this will definitely have some specific pattern. So at the receiver side, if you don't receive this pattern, you can at least say that error, you can detect that some error has occurred. Where it has occurred, you cannot say, but you can get the idea that some error has occurred. And finally, some desirable properties of the line code, that is transmission bandwidth. Now it is required that transmission bandwidth, as all of you know, it is scarce quantity, it should be as small as possible. Such line code you should choose. Power efficient, small amount of power required for the same probability and same bandwidth. The line code should have error detection and correction capability. In this case, out of these three, we have seen that the bipolar has error detection and correction capability, but it is not power efficient. It should have a favorable power spectral density, which we will study in more detail. In short, I just want to say that the power spread along the low frequency component should be 0, and the code should be transparent. Transparency means that none of the bits should be represented by 0 level, because otherwise if a long string of zeros comes, which in the case of on-off or bipolar is represented by 0 level, then it will create problem at the receiver side for the clock recovery. So this, at least you should know the properties of line code. In-depth analysis we will do in the class. Thank you for listening this lecture.